Okay, this is one way that you can collect your simulated data for your mark recapture study. So I have gathered some supplies. This is really similar to the lab in your lab manual, the mark recapture lab using beans. I didn't have red and white beans, so I got two really similar things that I could use for this. I have raw almonds and Marcona almonds, and so they're really only different in their color. They're pretty similar in their size and shape and texture and all that. So that's what we want. We want to mark an individual in a way that doesn't alter its behavior in its sample area or its ability to be caught in the trapping method that we're going to use. So our job is to figure out how many almonds are in this bowl or turtles are in the pond using the mark recapture method here. And this is my pond or my sample area, and these are my different sizes of sampling equipment. And so these cups would represent a high intensity of sampling, lots of traps left out for a long time. This would represent a medium sampling intensity, and this would represent a small, because we're capturing fewer with each sample event. So what you would do then is you would take your pond and you would, let's just start with the low intensity sample event, and grab your turtles. And this is a trap that a live trap. You're going to collect these guys and then you're going to count them. And so the number of almonds that we have in our initial population size, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I would record that in my notebook over here under the low effort table as the variable M, the number of marked individuals. So this would be 15 over here. So what I'm going to do to mark these is I'm going to replace these 15. I'm going to take them out of my sample. I'm going to pretend that I clipped the shell or did something to the turtles, and I'm going to add 15 marked individuals back into the sample area. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I wanted to get whole almonds that were the same size and shape as the almonds in my sample population. So now we have 15 marked individuals in here, and we're going to allow enough time. We're going to mix these up because we want to fulfill our assumption that marked individuals have time to distribute themselves evenly in the population. And then I'm going to take my same sample tool, my same trap, my same live trap, whatever, and I'm going to not look in my population. I'm going to get another sample of individuals, and I'm going to count what we have here. So the total number of individuals that we captured in this second sample event would be the total number of almonds, both the regular raw almonds and the marked Marcona almonds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 again. Okay, so that's S. I'm going to record that over here. And then the number of Marcona almonds in this group 2 would be R, would be the number of marked recaptures. So that's 2. So now I have all of the data that I need to be able to plug into that formula to get an estimate of the population size. And that would be what you would need to do with a low, medium, and high level of intensity to get all of the different estimates of the total population size of turtles in your pond.